Good morning, students. Today I am going to take up a topic of osmosis and then osmotic pressure. Students, osmosis. Osmosis is the phenomenon of flow of solvent molecules from a dilute solution into a concentrated solution through a semi-permeable membrane. Okay. Semi-permeable membrane is one which allows only selective particles. In case of osmosis, it allows only solvent molecules to pass through it. Consider this diagram. On my left hand side, there is a dilute solution. On my right hand side, it's a concentrated solution. जो बेटा रेड में है, this one is a semi-permeable membrane, SPM. Okay. According to definition, under normal conditions, solvent molecules will flow from dilute solution into concentrated solution through this SPM, and this thing is osmosis, from a dilute solution into a concentrated solution. Okay. But when we apply pressure, on concentrated solution, क्या होगा? Imagine करो, we apply pressure on concentrated solution, the flow of solvent molecules into concentrated solution will stop. Okay? That pressure, which is just sufficient to prevent the inflow of solvent molecules from dilute solution into concentrated solution, that pressure is known as osmotic pressure. Its symbol is pi, and this is our fourth and last colligative property. Okay? Mathematically, osmotic pressure is directly proportional to concentration of solution, or pi is equal to mRT, where m is molarity of solution. Okay, R is universal gas constant and T is the temperature of the solution. Okay, solve it further. Pi is equal to molarity NB, number of moles of solute, divided by volume of solution in milliliter into R into T into 1000. Okay. Standard units of osmotic pressure are Pascal, but it is generally measured in atmosphere or bar. Okay. Last but not the least, for exact calculation of osmotic pressure, we have to put extra symbol, that is I, our want of factor. So क्या है? Osmotic pressure is pi is equal to I into m into r into T. Okay. On the basis of osmotic pressure, students, solutions are of three types. First are known as isotonic solutions. Isotonic solutions are those solutions or those two solutions which have equal osmotic pressure. Consider we have solution A and solution B. If pi A is equal to pi B, these two solutions are known as isotonic solutions. Okay. Second category is hypertonic. Okay. Third is hypotonic solutions. These two terms are relative to one another, so have to be explained simultaneously. Suppose osmotic pressure of solution 1 A is greater than that of B, then solution A is hypertonic and the solution which has less osmotic pressure is known as hypotonic solution. I am explaining these three terms with an example. Consider a resin, egg or human RBC. This resin is placed in a concentrated solution. Inside this, it's a dilute solution. Okay, so according to concept of osmosis, where the water will flow, a solvent will flow, it will flow from a dilute solution into concentrated solution. Outward movement of water will take place. ऐसे ही होगा ना? दोबारा देख लो. The concentration of fluids in the resin is less than the concentration of solution which is present outside. So solvent, that is water in this case, flows from the resin into the solution. This phenomenon is known as exosmosis. Exosmosis, outward. Okay, this will result in shrinking of the size of resin. Fluid कम होएगा, क्या हो जाएगा? Shrink हो जाएगा. Technically, it is known as plasmolysis. The shrinking of resin because of exosmosis is known as plasmosmosis. यहाँ पे हाइपरटोनिक कौन था? हाइपोटोनिक कौन सी सॉल्यूशन है? गेस कर सकते हो? Dilute solution is hypotonic. Concentrated solution is hypertonic. Okay. Next example देखो students. यहाँ पे same है. Resin. Suppose kishmish is placed in water, a dilute solution. So concentration inside the resin is more. It is concentrated solution. Outside concentration is less, so it is a dilute solution. अब क्या होगा? Solvent molecules, water molecules will enter into the resin. Results in swelling of the resin. क्या हो जाएगा? Size increase होएगा. This phenomenon is known as osmosis. and osmosis results in swelling and ultimately rupture of the particle of the substance which is taken, known as hemolysis. Okay students, terms clear हैं? दोबारा बोल रहा हूँ, exosmosis, endosmosis, plasmolysis, hemolysis, hypertonic, hypotonic, last is isotonic. Isotonic में देख लो, two solutions which have same osmotic pressure, that is that solutions are known as isotonic solutions. The example note करो, 0.91% its mass by volume solution of NaCl, commonly known as saline. Hospitals में name सुना होगा आपने, saline. It is isotonic with human RBCs. So जब भी saline ट्रिप हो जाते हैं उसकी concentration क्या होती है? That is 0.91%. It's isotonic with human red blood corpuscles. Okay. Lastly, students, you know what is osmotic pressure? It's the minimum pressure which is applied on concentrated solution to prevent the inflow of solvent molecules into the concentrated solution. That is osmotic pressure. What if we apply external pressure which is greater than pi, which is greater than osmotic pressure? Suppose यहाँ और press करो यहाँ पे, ultimately होएगा क्या? Now solvent particles will start moving from concentrated solution into dilute solution. ये होगा ना, concentrated solution into dilute solution. Move करेंगे, कौन करेंगे? Solvent molecules. This phenomenon is known as reverse osmosis, RO. Okay, and fully आपको पता होगा RO कहाँ पे यूज करते हैं? It is used for purification of water. So घर पे जो RO purifiers हैं, that work on principle of reverse osmosis. Students, this is it for the osmotic pressure, osmosis or reverse osmosis. With this topic, chapter solution is over. So इसकी पूरी NCERT exercise, exemplar problem या previous year questions यहाँ पे भी आपको online offline available हैं. कुछ तो मैं description पे नीचे भी डालूंगा इसके related हो. इन्हें solve करो, doubts पूछो. ठीक है जी? Take care. Thank you.